All right, we're trying a screen capture video to go over one of our math topics from yesterday. Remember that we're studying the broad category of geometry, which looks at shapes, plane figures, even 3D shapes. And this week, we're studying one particular type of plane figure, a quadrilateral. A quadrilateral is a polygon with 4 sides. So let's look at how we can identify 4-sided figures. Here are 4 examples of the 5 that we're going to learn of 4-sided figures. We've got rectangles, squares, rhombuses, and trapezoids. You'll notice that all of these figures have the same number of sides. They all have 4 sides. Now, in a square or a rhombus, all the sides have equal length. But in trapezoids and rectangles, the side lengths differ from one another. A rectangle has 2 pairs of equal sides. Look at those sides going this way and those other parallel sides going this way. Those are equal to each other, but they are not all 4 equal. In a trapezoid, there are 2 parallel sides, but the side lengths can all differ. There might be some that are equal, and there might not be some. Next, let's move on to the angles. Because each shape has 4 sides, they all have 4 vertices or points. At those points where 2 sides come together, it creates an angle. Remember in the last unit, we talked about acute angles, right angles, and obtuse angles, right? So now we're going to look at the angles of quadrilaterals. Every single quadrilateral has 4 angles. In rectangles and in squares, all of those angles are right angles. So they're equal to each other, and they're all exactly 90 degrees. In a rhombus, there are pairs of equal angles, just like a parallelogram, which is another shape we'll talk about soon. And in a trapezoid, there are 4 angles. Sometimes some of them are equal, and other times they're not. Trapezoids can be a little bit tricky. All of these quadrilaterals have 4 vertices or points. Vertices in singular is vertex, so just to make sure you don't get confused with that. So we talked through these mystery shapes. We looked at the qualities of each shape to determine what it was. A is a rectangle because it has 2 long sides and 2 short sides. There are 4 90-degree angles, and there are 2 pairs of equal sides and parallel sides. B is that mystery shape we were talking about before. B is a parallelogram. All right, so in B, we're going to see 2 sets of parallel sides, but not necessarily 90-degree angles. C is a rhombus. Every side length is the same. 2 sets of angles are equal, but they're not necessarily 90-degree angles. That D, that's a shape that we all know and love. It's a square. It is the most regular of all quadrilaterals because all the sides and all the angles are equal. Finally, at the bottom, we see a trapezoid. It's noted by its 2 parallel sides, and the other sides can do a little bit of what they want. All right. This is a brief chart that you can see in your PowerPoint, and that will show you how the properties line up with each of the types of quadrilaterals. These quadrilaterals are given names, and the properties tell you exactly what that name means. What do I mean when I say a square? I mean that all those sides are equal. The opposite sides are equal. There are 2 pairs of parallel sides, and all of the angles are right angles. All right, so we can also identify figures by their property. And we've already gone over this list of what each figure is. Squares and rectangles, they are very noted because they have all 90-degree angles. So that's something that we can look at. And whenever we're missing an angle in a square or a rectangle, we know that it has to equal 90 degrees. Similarly, if we see a quadrilateral and we don't know what type of shape it is, if we notice it has all 4 90-degree angles, that means it's a rectangle or a square. Now, put on your thinking caps. I want you all to consider, are all rectangles squares? Are any rectangles squares? Are all squares rectangles? And are any squares rectangles? I'm not going to spoil the answer to those questions just yet, but I do want you to think, right, like mathematicians. And people who study geometry are trying to categorize these shapes by their different properties. So think about whether any of these categories are mutually exclusive, right? No rectangles are squares and no squares are rectangles, or if they might overlap, like those Venn diagrams we've practiced. The next thing we know about all quadrilaterals is that when we add up all the angles that are inside the quadrilateral, it has to equal 360 degrees. Now that we know this, we know all the angles add up to 360 degrees, we can use this to find missing angles. This is when we use mystery math or algebra. So when we solve this mystery, we're looking at the three angles we know, and we know the total, but we don't know one of the things missing. So we can visualize a bar diagram where the total adds up to 360, where there are 4 parts to the bar. We know 3 of the parts. When we add those 3 parts we know and subtract them from 360, we get our missing angle, which is 105 degrees. Now, I want you to try to find this missing angle. Here, we know the total. It's 360 degrees. And we know 3 of the angles. We can go through subtracting from 360 to find that missing angle. So first, let's subtract angle C. We have 360, and we're taking away 120. Well, 360 minus 100 is 260. We take away 20, and that's 240. Okay, this is how we can do it with mental math. So we have 240, and now we need to subtract angle B. We're going to subtract 95 degrees. Well, 95 is pretty close to 100, so let's use that for our mental math. 240 minus 100 is 140, and we're going to add those 5 back to compensate. So we have 145 degrees. Now we need to subtract again. All right, we're going to subtract angle A. From 145 degrees, we're going to subtract those 5 degrees to get 140. And now we're going to subtract those 80 degrees. 140 minus 80 is 60. So the angle D must be 60 degrees. See, we've worked together using what we know about quadrilaterals. We've used what we know about the angle measures of the interior angles of quadrilaterals to solve a mathematical mystery. Check out again for another video